Hello, on this lesson we're adding and subtracting rational expressions, which are kind of just big messy fractions. Okay, so as you can see, they get worse and worse as we go along, or there's more to them as we go along. I'm not going to say worse because I think they're fun, but anyway, before I show you the adding and subtracting of these, I'm just going to throw out a couple of problems of just normal fractions because the concept is the same concept, but it gets messier with the kind of numbers and variables and all that we're going to be using. So let's say that we were going to add 5/8 plus 4. Trying to think of something that would work out here. Over 28. Okay. Now let's do 3 over 28, so that wouldn't be one that would simplify. Okay, so what I need to figure out is a common denominator, because we have to have these in the same number of parts, if that makes sense, for us to be able to add them together. So the denominators have to be the same. Now, one thing that you can do with this is take each one and factor it into primes. So factor it out, and then we're going to see 28's 4 times 7, so that would be 2 times 2 times 7. And then a technique that I learned a long time ago when I was teaching pre-algebra was to just circle one of your denominators. So let's say we circle the first one. It doesn't matter which one you circle, just pick one. So I circled the first one, and then you have to ask yourself the right question. Are there any factors on my second denominator that I haven't already circled? Well, if you look at this, you can see, hey, I've already circled 2 2's, so that's good, but I have not circled the 7. And then to find my least common denominator, right, I would multiply the 8 times 7, right, because 2 times 2 times 2 is 8, which is 56. So now I have to rewrite my two fractions with a new denominator of 56. And I multiply by whatever it takes. Let me write that a little bit smaller to get the 56 in my denominator on each one. So on the first one, I need to multiply by 7, right? Because 7 times 8 is 56. So I'm going to multiply my fraction times 7 over 7. Now, 7 over 7 actually equals 1. So it's the same as multiplying by 1, which gives me an equivalent fraction. And when I write an equivalent fraction, then it looks different, but it has the same meaning because it simplifies to 5/8. And then on the second one, I would need to multiply by 2 to get 56. Right, 2 times 28 is 56. And so I multiply by 2 in the numerator and denominator. And then I simply add the numerators. So that's going to be 41 over 56. Now, we can use this same technique for all of the examples I'm going to show you to find the LCD and rewrite them with that same common denominator. I think I'll just go on to the next example, but it's the same concept, okay? So now let's just look at that. Notice what it says: factor each denominator completely. The LCD is the product of all unique factors, each raised to a power equal to the greatest number of times that the factor appears in any factor denominator. Now, I think the way I word my technique is easier, and it technically is doing what this says, right? We're going to factor, we're going to circle, and we're going to decide if we've put all the factors possible into our common denominator. So on this first 10 over 7x, that's 7 times x, and this is 2 times x. And I can circle either one. So I'll circle the second one this time. And then I have to ask myself the right question: are there any factors on the 10 over 7x that I haven't already circled? Well, I'm hoping that you can see that it would be a 7. And then to get my common denominator, I'm going to multiply 7 times 2x. So my LCD is 14x. Okay, so now I have to rewrite both fractions with a denominator of 14x. So I want it to look like this. And then I decide, what do I multiply by? Well, to get 14x, I multiply 7x times 2. So that means I'm multiplying by 2 over 2. Remember, I can't just randomly multiply one part of this. I have to multiply by 1, and so I'm not changing the meaning. I'm just writing an equivalent fraction. So that's going to give me 20 over 14x. And then on the other one, I'm going to multiply it by 7. So that's 35 over 14x. And then I'm add the numerators, right? The 20 and the 35. So that's 55 over 14x. Now I've already taught you to simplify fractions. You have to learn that before you get to this. And we're going to check and see, can we simplify this any? Well, 55 is 5 times 11 and 14 is 2 times 7. All prime numbers, nothing in common. So that means that we are finished. And this is our answer. Can't make a very good circle there. I have some extra stuff going on. Okay. And then I erased my circle. So let's go on to the next example. Okay. Now on these, you can write all the x's out one by one when you're factoring the denominators. So 11x is going to be 11x to the fourth will be 11 times x times x times x times x. Made that one kind of big. And then 4x squared is 2 times x times x. Okay. Now you can circle either one of them for this technique. Remember, circle one of your denominators and then ask yourself the right question. So are there any factors on my second fraction that I haven't already circled? Well, if you look at this, I've circled 4 x's. This one just has 2, so that's taken care of, right? X times x. But I haven't used the 2's yet because all I had on the first one was an 11. Okay, so now I multiply everything circled. So 11 times 4 is 44. So my LCD is going to be 44x to the fourth. So this is the denominator I need when I rewrite these. Let me write these out again. And notice we're subtracting this time, so you want to be careful and pay attention to the fact that you have a minus sign. I'm trying to rewrite them with denominators of 44x to the fourth. Okay, so on the first fraction, I need to multiply by 4, and I don't have to multiply by any x's because I already have x to the fourth. So this one's just going to be times 4. 4 over 4 equals 1. Remember, we're always multiplying by 1. On the second one, I'm going to multiply by 11, and I have to have another x squared to get x to the fourth. Remember, when we're multiplying variables, we add the exponents. So my numerator is going to be 11x squared. So next step is to add these or subtract, in this case subtract. So it's 16 minus 11x squared over 44x to the fourth. Now, if we could simplify this, we would do so, but you would need to be able to factor out a common factor, and there is no common factor to factor out. So that one's done. Now, this one may look messier, but the truth is it's probably easier because, first of all, it's already in factored form. So my LCD hopefully is easy to figure out. This one's already factored. what's missing on the second fraction that, right, I circled these. Are there any factors here that I haven't circled? Well, there's not, right? Because x plus 4 has already been circled. So that means my common denominator is both factors. And I don't have to rewrite the first fraction at all. Okay, so it stays the same. Right, x minus 5. Whoops. Kind of got that running together. Okay, that's being slow. X minus 5 times x plus 4. And then I'm going to write a minus sign up here with the 2 so it doesn't get lost. And then I'm multiplying, let me just make that shorter. I'm going to multiply by the missing part. And that's going to be x minus 5 over x minus 5. Now I'm going to put parentheses around these because that just shows that factor. Now I multiply through with the negative 2, and I'm going to then add my numerators together. Remember, this was subtraction, but I made it plus a negative, right? Add the opposite. So my numerator is 4x minus 2 minus 2x plus 10 when I distribute the negative 2, and that's the very reason that I put my negative sign up there with the 2 so that I don't mess up on signs. It's common to miss the sign of the negative 2 times negative 5 if you forget to write your negative in front of the number and leave it down between the two fractions. Okay, so then we're going to combine like terms. So that's 2x plus 8. And then we see if we can simplify this at all. And it looks like it's going to simplify. So I'm going to factor out the 2 in the numerator. And then write my denominator. I don't know what's happening with my surface right now. Sometimes it does some weird little things. Come back. All right, so that should have been a plus x plus 4. And then I can remove x plus 4 because that equals 1. So my answer would be 2 over x minus 5. Now I don't need to write the parentheses around the x minus 5 since that's the only thing left at this point. All right, so finished with this. I'm going to start on the next just realized that said okay with unlike that all said the same thing. I'm going to start on the next part. This is just showing the steps that we find the LCD, we write each of them with that so that we have an equivalent expression with that same LCD. Then we add or subtract numerators and write the result over the common denominator and simplify. So we have been doing that on each of these questions. I'm going to stop this video and pick this up on the next one.